as the global auto industry accelerates toward electrification. Most manufacturers are betting heavily on hybrids as the safest bridge between traditional combustion engines and full electric vehicles. Mazda, however, has chosen a very different direction, one that could prove to be one of the smartest long-term strategies of this decade. Rather than piling on heavy and complex hybrid systems, Mazda invested deeply in something many believed was finished, a next-generation inline-6 diesel engine. And by 2027, this engine may quietly outperform many hybrids where it truly matters: real-world efficiency, durability, driving feel, and total cost of ownership. This isn't nostalgia, it's engineering logic. Mazda's Inline-6 diesel isn't a recycled, old, school oil burner. It's a modern, clean, high torque, low stress powertrain designed around cruising efficiency, mechanical simplicity, and long-term reliability. While hybrids look impressive on paper and in urban test cycles, Mazda's diesel strategy is built around how people actually drive long distances, sustained highway speeds, towing, and real-world loads. To understand why Mazda's approach may age better than hybrids by 2027, you have to look past marketing and into physics, thermal efficiency, and ownership reality. Most hybrids combine a small turbocharged gasoline engine with electric motors and a large battery pack. In city driving and short commutes, this setup works well. But as vehicles grow heavier and regulations tighten, hybrids are becoming increasingly complex. Mazda engineers identified several key problems with this direction: growing vehicle weight from batteries, motors, cooling systems, and power electronics reduced efficiency at sustained highway speeds. Long-term reliability risks as mechanical and electrical systems age together. Rising replacement costs for batteries and electronics once warranties expire. Instead of layering technology on top of technology, Mazda chose to perfect the core engine itself. The inline-6 diesel is the result of that philosophy. Inline-6 engines are naturally balanced. Unlike V6 layouts, they don't require balanced shafts, complex crank designs, or additional vibration control. This matters more than many realize. A naturally balanced engine runs smoother, experiences less internal stress, reduces component fatigue, and maintains efficiency over time. When paired with diesel combustion, which is already more thermally efficient than gasoline, Mazda created a powertrain that doesn't rely on electrification to deliver real-world efficiency. This engine is low stress by design, and that's where it quietly outperforms hybrids. Hybrids excel in stop-and-go traffic, but once cruising at highway speeds, the electric motor contributes very little. At that point, the vehicle is simply carrying extra weight. Diesel engines, especially inline-6 designs, do the opposite. At steady speeds, they operate close to peak thermal efficiency. Torque is delivered at low RPM, and fuel consumption remains stable even under load. By 2027, as long-distance commuting increases again and highway driving becomes more dominant, this advantage grows more relevante less. Mazda's diesel maintains efficiency when climbing grades, towing, or carrying passenger situations where hybrids often revert to gasoline power and lose their edge. Hybrid systems often advertise impressive torque numbers, but much of that torque comes from temporary electric boost that depends on battery charge. Mazda's Inline-6 diesel delivers continuous mechanical torque. That difference matters. Diesel torque is always available. It doesn't fade as batteries drain. It doesn't generate excess heat in motors or inverters, and feels linear and predictable. For SUVs and crossovers, this translates into effortless acceleration without constant gear changes or artificial power blending. It's torque you can rely on at any speed, in any condition. By 2027, many early 2020s hybrids will be reaching the end of their warranty coverage. That's when the real cost story begins. Battery degradation, cooling system failures, inverter wear, and integration issues between mechanical and electrical systems will become more common. Mazda's Inline-6 diesel avoids most of these risks. Its core components are mechanical, robust, and designed for long service intervals. Diesel engines also operate at lower RPMs, reducing wear on bearings, pistons, and valvetrain components. Mazda further optimized internal friction, oil control, and combustion stability key factors for long-term durability. For owners who keep vehicles beyond 5 or 7 years, this matters far more than short-term fuel savings. Diesel's reputation suffered due to outdated designs and regulatory scandals. But modern diesel engines are fundamentally different. Mazda's Inline-6 diesel uses advanced exhaust after treatment, precise fuel injection, optimize combustion timing, and reduce particulate formation at the source. In real-world driving, especially at highway speeds, modern diesel emissions can be surprisingly competitive with hybrids, particularly when factoring in the environmental cost of battery production and disposal. By 2027, life cycle emissions will matter more than tailpipe numbers alone. And under that lens, Mazda's approach performs far better. Mazda has always prioritized driving engagement. Hybrids, despite their efficiency, often dull the driving experience. Common complaints include artificial throttle response, rubber band CVT behavior, inconsistent braking due to regeneration, and uneven power delivery. Mazda's Inline-6 diesel delivers smooth, linear acceleration, natural engine braking, stable throttle response, and consistent power at all speeds. This benefits not only enthusiasts, but everyday drivers who value confidence, predictability, and control. SUVs and crossovers will continue to dominate global markets through 2027 and beyond. These vehicles are heavy, tall, and frequently used for long trips, classic diesel territory. Mazda's Inline-6 diesel match vehicle mass nature reduces strain under load, eliminates the need for oversized hybrid systems, and maintains performance without sacrificing range. In midsize and large SUVs, it's simply a better match than small turbo hybrids constantly fighting physics. While incentives may favor hybrids up front, total cost of ownership tells a different story. Battery replacements are expensive. Out-of-warranty electronic failures will rise. Diagnostic complexity increases labor costs. Mazda's diesel relies on proven service. Procedures, avoids high-voltage components, maintains predictable maintenance schedules, and benefits from diesel's long service life. Over a decade of ownership, this difference becomes substantial. Mazda isn't anti-electrification, it's anti-wasteful electrification. The Inline-6 diesel isn't a step backward, but a bridge toward a future where efficiency is measured honestly. Durability is valued again, and engineering elegance beats technological clutter. By 2027, as many hybrid owners face aging systems and rising costs, Mazda diesel drivers may still be cruising effortlessly, refueling quickly and accumulating miles without drama. Mazda's Inline-6 diesel represents something rare in today's auto industry: confidence in fundamentals. Instead of chasing trends, Mazda refined engine balance, combustion efficiency, torque delivery, and mechanical simplicity. The result is a powertrain that may outlast and outperform many hybrids not in lab tests, but in real life. Hybrids aren't going away, but they aren't the universal solution they're marketed to be. For drivers who value range, torque, longevity, driving feel, and honest efficiency, Mazda's Inline-6 diesel could be the smarter choice well into 2027 and beyond. In an industry obsessed with adding more, Mazda chose to engineer better, and that decision may age exceptionally well.